the radiation so in radiation concept, okay, uh, we don't look at the whole electromagnetic spectrum. Okay, we will restrict ourselves to this range of 10 to the power of -1 to 100, that is 10 square. So this is our thermal radiation range. Okay, strictly speaking, so we will be restricting ourselves only to this thermal radiation range. Right. So while we speak about this thermal radiation range, what happens in this? What is the physical mechanism of heat transfer for radiation? Somebody speak out. You know what is the physical mechanism of heat transfer for conduction and convection? Now I'm speaking about the radiation. Okay, if you speak about conduction, it is Lari's vibration. If you come to convection, it is molecular diffusion, molecular collision. That is a physical mechanism of heat transfer. Coming to your radiation, what is the physical mechanism of heat transfer? Speak out.
Electromagnetic waves.
Electromagnetic waves. The energy is transferred in form of a packets called quanta, that is the electromagnetic waves. Okay, so energy is transferred. So when we speak about these electromagnetic waves, these electromagnetic waves can have, the wavelength from 10 to the power of -12 on my left to the 10 to the power of 12 on my right. So that much huge spectrum will be there for electromagnetic waves. So it is from 10 to the power of -12 to 10 to the power of 12 micron meters of wavelength can be there. Okay, in this, if you look at 10 to the power of -4 to 10 to the power of -2, you can see there the X-rays are falling in that range. For your ultraviolet, you have 10 to the power of -2 to 10 to the power of minus 1, I guess. Okay, even bit more than that. And again, farad is from somewhere around 1 to, so here we go. So there are various ranges for the kind of radiation that we go, but we are interested only in thermal radiation range. We are interested only in thermal radiation range. Okay, and this will fall in the wavelength of 0.1, that is 10 to the power of -1, to 100, that is 10 square micron meter wavelength. Okay, this is the thermal radiation range. So in this range, we speak about in our radiation unit and in our heat transfer subject. Then, see, the interesting part is in the thermal radiation range itself, there is chance for visible range and infrared range and ultraviolet range also. So within this thermal radiation range, these three things will fall. So let us speak about the infrared range. Now, if you speak about the infrared range, it will fall from 1 to 100 micrometer wavelength for infrared radiation. So the infrared radiation is nothing but a thermal radiation, right? There is one more thing, that is a visible range, and this visible range will fall around 0. 0.05. No, it's from 0 to 0.5 micron wavelength is for visible range, and you have ultraviolet. Ultraviolet will actually start from 10 to the power minus 2, that is 0.012. It will cross your thermal radiation range, and it will come to somewhere around 0 micrometer. That will be your ultraviolet radiation. That is your UV radiation range. So these things you should keep in mind. So our major focus will be upon this point. That is, we are interested only in zero point 0.1 to 100 micrometers wavelength. That's the point there. Right. Moving on, let's speak about something called as incident radiation. For that, let me take a body here. This is the body. On this body, let me say I have sent a radiation here. This is a incident radiation. Let me say that Q is the heat that is coming onto this body. Okay, it is incident on the body. Now, when I leave this much of radiation on this radiation will get reflected. A part of it will get reflected. Let me call that as QR. And a part of it might get transmitted also. So it need not be reflected. A part of it can be. Let me choose some different color here. This is getting transmitted, and the part of it is getting absorbed. So what's happening is you are supplying Q here. This Q is spent in three different ways. Firstly, it is reflected, and next part it got transmitted, and then it also got absorbed. So when a incident radiation is falling on a given body, it may get reflected, it may get transmitted, it may get absorbed. Anything can happen. A combination of two or three can also happen in a given case. So to understand this appropriately, we will come up with the definitions of reflectivity and then transmittivity and absorptivity. Okay, these are the three definitions we must know. This reflectivity is shown with rho, transmittivity is shown with tau, absorptivity is represented with alpha. Okay, so these are the things. So if I have to define my reflectivity, it is a fraction of incident radiation, fraction of incident radiation that is getting reflected, getting reflected. Okay, this transmittivity is fraction of incident radiation that is getting transmitted. Okay, this is fraction of incident radiation that is getting absorbed. So these are the definitions of these terms. Okay, so if I have to give formulas for this one, okay, how to give formula for each one. See, if you look at this energy balance here, how this energy balance is going to be, it's going to be like capital Q, that is incident, is equal to QR plus QT plus QA. That's what the energy balance is here. So I'm repeating it again here. Q is equal to the incident radiation can be equal to reflected plus transmitted plus absorbed. Now what I'll do, I will write one on this side and I'll take Q onto the each term here. That is QR by Q plus QT by Q plus QA by Q. So if I take it, what is this QR by Q? Somebody speak out.
Fluctuating.
It, it is nothing but your reflectivity. What is Qt by Q? It is a fraction of incident radiation that is getting transmitted. So it will be transmittivity. What is QA by A? It is a fraction of incident radiation that is getting absorbed. That is alpha. So what I got ultimately here is simply alpha plus tau plus rho is equal to 1, meaning the sum of absorptivity, transmittivity, and reflectivity will be always equal to 1. That's the point here. Okay, so based on this alpha, rho, and tau, we do the classification of radiative bodies. We do classification of radiative bodies. So how do we do it? Let us see. Okay, based on alpha, comma, rho, comma, tau. Okay, let me say what is my white body. Okay, what is the meaning of a white body? So white body is not something that is white in color. Okay, according to us, white body is a body that has best reflecting capacities. That is a perfect reflector. Okay, white body is a perfect reflector. So if it has to be perfect reflector, what should be the values for alpha, rho, and tau? Alpha key, rho key, tau key values and chapandi. If it is a perfect reflector,
No one.
okay. What is one? I just had one.
True. Reflected.
Rho is equal to 1. So if rho is equal to 1, the other two terms, that is alpha and tau, should be equal to 0 because sum of these three is equal to 0. So that's what white body is. Let's move to the next one. That is a black body. What is black body?
Perfect observer.
Alpha equal to 1. It's a perfect absorber. Very good. It's perfect absorber and perfect emitter also. Emissivity we did not go. Oh, okay, let's stick to our absorptivity itself. It's a perfect absorber. Then what should be alpha, rho, and T? Tau?
Alpha 1.
Alpha equal to 1. Alpha should be equal to 1 and your rho and tau will be equal to 0. Then let me take a transparent body. Transparent body is nothing but it's a perfect transmitter. So whatever comes as an incident radiation, it will completely transmits. So then what shall be alpha rho T? The rho and tau, sorry, the alpha rho and alpha should be equal to 0 and the tau should be equal to 1. Okay, because it doesn't reflect anything, it doesn't absorb anything, it just transmits. So that's how the transparent body is defined. Let's move to one more classification, that is opaque body. Can somebody tell me what is opaque body?
Light cannot be transferred.
No transmission through it. Okay, zero transmission. When there is zero transmission, what is the meaning of it? The tau will be equal to 0 and the remaining two terms, that is alpha and rho, will be equal to 1. The sum of absorptivity and reflectivity will be equal to 1 for a opaque body. Okay, so let us speak about something called as a real body or a non-black body. This is E actually. Real body or non-black body. If this is the case, what will be the value of alpha, rho, and tau? చెప్పండి.
Less than 1.
Alpha is not equal to 0 and rho is not equal to 0 and tau is not equal to 0. Okay. In reality, you cannot find a perfect absorber, you cannot find a perfect reflector and perfect transmitter. These things are not possible in reality. So they'll not be equal to 0 any times. Constructing such sort of things, developing such sort of things is really a challenge. And these values, alpha will be less than 1, rho will be less than 1, and tau will also be less than 1. And for a real case, alpha plus alpha plus rho plus tau is equal to 1. That's the thing regarding a real body. Hmm. Here, let me speak about gray body also. Okay. It might be a bit advanced right now, but okay, I'll tell you what it is a gray body. See, gray body is a body having emissivity less than 1. Emissivity less than 1. I must tell you what is the ability to emit. Okay. The emitting capability, if I speak about, you take any body, it can be any body. It can be a bottle, it can be a pen, it can be a book, or it can be something like sun, anything. Okay, you take it, it will have certain temperature. You cannot find a body without temperature. Any body will have so and so temperature. It should have some temperature. If it is having so and so temperature, it will emit something into the atmosphere as T to the power of 4. Okay, power of T to the power of 4, it will be emitting some energy. That energy is called as a emitted energy. Okay, that part is nothing but the thermal radiation we are speaking about. So every body will emit, but if this emission is perfect, then you call it as emissivity equal to 1. Okay, but in reality, emissivity equal to 1 is very tough. That's why most of the times you will have bodies which are having emissivity less than 1, then you call that body is having emissivity less than 1 is called as gray body. For completeness, I'll tell you the emissivity formula also. It is by emitted power, by emitted power with black body, that is emitted radiation by black body radiation. emitted radiation by black body radiation. This is the definition of emissivity. Okay, so emitted radiation, that's the thing. So let us say what is black body also with respect to the emissivity. So what will be the epsilon value here
One.
for black body? It is equal to 1 because emissivity is equal to E black body by E black body, what will be equal to the same value. So it will be giving you 1 and this will be less than 1. This is non-black body emitted radiation. So that's the classification based on alpha, rho, tau, and I also added emissivity actually. So to make it a bit simple, I have added emissivity also here. Emissivity is nothing great. It is the ratio of emitted radiation to the black body radiation. Right. We're done with the classification based on alpha, rho, and tau. Let's move to the classification based on reflection of body. These theory things are most of the times asked in 2 marks question. That's why I'm clearly explaining all this. So please follow this, make a notes of whatever I'm saying now. So in this reflection of the bodies concept, we have first one called as a specular body. Okay. In specular body, what happens is if this is your body like this, if you are sending some incident radiation here like this, then it will reflect with the same angle, whatever the angle that you have here on this side, the same angle you will have on the other side also. That is angle of incidence with respect to vertical is equal to the angle of reflection with respect to the vertical. The angle of incidence and the angle of refraction, theta I is equal to theta R. So that's why the specular bodies are also called as angle dependent reflection or reflective bodies. Okay. So that's what the specular body concept is. This is one kind of a classification. The other classification is diffusive body. Diffusive body. If I take a diffusive body, this is a body, and a radiation is incident on it, and this will reflect in all direction. It will reflect like this. 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 This, and so on. It can reflect in any direction. That's the point here. So reflection takes place in all directions. That's the point here. Right? That's why it is called as angle dependent, sorry, angle independent. Angle dependent is this one. That is specular body is angle dependent. Reflective body is angle independent. reflective or reflection. Anything is okay. Reflective bodies. So that's how you differentiate the radiative bodies based on the reflection of the body. Then we will move to the concept of laws of radiation heat transfer. So can you tell me what is the law governing radiation heat transfer? Please speak out.
Stephen Boltzmann.
Stephen Boltzmann law is the basic law. Okay, but along with that, there are other laws that are given to us in syllabus. Those things I am writing here. It is Wayne's law or Wayne's displacement law. And the second one is Stephen Boltzmann law. The third one is Kirchhoff's law of radiation. Now let me quickly go to the syllabus. It is the syllabus for heat transfer. Here it is. We go to the radiation. Here is the radiation thing. What he has given us? He has given the laws of Planck, Wayne, Kirchhoff, Lambert, Stephen Boltzmann. So many laws are given there. Okay, all these laws you can find it in the data book actually. Let me quickly go to my data book and show all these laws to you there. I should have downloaded prior, but I'm sorry. See here, you go to page number 90 in data book. So there you have every law. You have the Kirchhoff's law, you have a Wayne's displacement law, you have the Stephen Boltzmann law, Planck's law. Okay, whatever law you want, you have it there. Okay, so for Kirchhoff's law, this is the story. Wayne's displacement law, this is the story. Stephen Boltzmann, this is the story. Planck's law, this is the story. So basically, first three things I'm going to discuss now. Why I'm showing it in data book is if you forget, you can use the data book during your exam if this question is asked. That's the intention of showing it in the um, data book. Anyways, you have to by heart it for yourself if it is a preparation for competitive exam. Anyways, coming to Wayne's law, what it says is the product of the wavelength into the temperature will be equal to a constant value. This is what it says. And most of the times, this wavelength into the temperature product is equal to 2898. Um, the unit of this 2898 will be micron meter. That is the unit of your wavelength into the Kelvin. So this is what your Wayne's law says or Wayne's displacement law says. The product of wavelength and absolute temperature. T is temperature absolute. When I say absolute, what is the meaning? You are measuring it in Kelvin. So that's what Wayne's law or Wayne's displacement law is. The second one is Stephen Boltzmann law. We have already discussed this in the first unit itself. This is the major law that governs the radiation. So if I have to write it, it's like Q is simply put, it is Q is proportional to T to the power of 4. So what it says is the radiation heat transfer is proportional to the fourth power of temperature. And if I have to represent it for a black body, it is like this. It's equal to sigma into T to the power of 4. Sigma being the proportionality constant, it's called as Stephen Boltzmann constant. And somebody tell me what is the value of the sigma. Please speak out.
5.69
5.69
into
into
10
minus 9
5.67
6
into 10 to the power
or
minus
minus
8
8
watt per meter square Kelvin power
4.
4. This is the constant value of sigma. You have to remember it. It is 5678. The logic for remembering this is 5678, but even this is also available to you in data book if you forget. Okay, it's 5678. 5.67 into 10 to the power minus 8 watt per meter square Kelvin power 4. Okay, don't get so much dependent on your data book. That's not a good habit, but for the sake of your comfort, I'm saying it. Anyways, so that is Q measured mm, without taking area into account. Area should be taken into account. So if I have to measure that, see, what we do is we represent these things with E. Generally, this is shown with E in the nomenclature. QB, you will introduce sigma into A into T to the power of 4. This is the general thing that is followed. So let's follow this one itself. So that's the story of Stephen Boltzmann. Even if you have to measure the non-black body, you will introduce the emissivity also. That is one way. And if you want to represent between two bodies, Q12, it is sigma into A into emissivity existing between 1 to 2 and T1 to the power 4 minus T2 to the power 4. Okay, all these things we have seen already. So that's all about your Stephen Boltzmann law. So let's quickly move to the Kirchhoff's law of radiation. So please look at your data book and tell me, what does it say? Data book choose చెప్పగలుగుతారా? See, what does it say is, it says that for a non-black body, the alpha value will be equal to the emissivity value. That is, emissivity is equal to absorptivity. Absorptivity. That is, epsilon is equal to alpha. That's what Kirchhoff's law of radiation tells you. Yeah, this is the key takeaway from Kirchhoff's law of radiation. Emissivity is equal to absorptivity. So that is the thing regarding laws. And fourth one also, let us write. Even I don't remember this fourth one. I will use this data book for this purpose. So where's my data book? Here it is. Let me erase it. For this one, Planck's law. This is a formula. So Planck's law of radiation. What it says is, it says that the black body radiation with respect to the wavelength is equal to C1 into lambda power minus 5 by e to the power of C2 by lambda t minus 1. This is the formula for black body radiation with respect to the wavelength as per the Planck's law of radiation. What is C1 is given here. What is C2 is also given in data book. those things you write there, where C1 is equal to 0.374. I'm writing it from here, the data book 374,177,107 into 10 to the power of minus 15 watt per meter square, and the C2 is equal to 0.014. I'm writing it again from the data book 0.014 387752. See, this Planck's law is only asked for your exam purpose. So that is the semester exam purpose. For that, you can refer to this data book and see it from the data book and write it directly. Even I don't remember it for myself. Okay. Mm, So that's the thing regarding the thing. Then we have something called as a Lambert cosine law. Okay, this Lambert cosine law, I'll be teaching it in the next class. So that will be useful in a different way. We have covered Planck, vein. Planck is done. Vein is done. Kirchhoff is done. Stephen Boltzmann is done. So only Lambert is pending. That we will see in the next class. So going forward, let us look at a very important concept called as a shape factor concept. It is a shape factor concept in the syllabus. It is very, very important concept as far as your radiation is concerned. By definition, shape factor is actually the radiation or the fraction of radiation energy that is diffused from one surface and strikes on the other surface directly without any intermediate reflections. Let me explain this. Okay, let me take a body 1 here. This is a body 1, and I'm only taking the right side surface, the top, left, and bottom. I have insulated it, and I'm taking a body 2 here. So, students, tool draw చేద్దాం ఇక్కడ. Let's draw two. This is insulated on the other side, except this left, top, bottom, and right is insulated. So that is only 1 and 2 are interacting here. While it's interacting, you will have Q1 coming out of it. This Q1 is coming out and it's going like this. A part of it is coming onto Q2, part of it is coming onto body 2, part of it is not coming. Okay. So Q1 is the energy emitted by body 1. Similarly, if I write for Q2, it is the energy emitted by body 2. Okay, that is a Q1 and Q2. Here we will have something called as Q12. Q12. Q12 means it is energy emitted by body 1 and received by body 2. So do you understand what is the meaning of Q12? Whenever I write Q12, the meaning of it is energy emitted by body 1 and received by body 2. If I am writing Q21, what will be the meaning of this? Energy emitted by body 2 and received by body 1. The reverse of it actually. Okay, that's what the meaning of Q1. Now let us tell what is the shape factor now. Shape factor means it is a fraction of radiation that is received or diffused from one surface on the other surface directly. Directly is very important here, without any intermediate reflections. That is the definition of your shape factor. Shape factor can be defined like this. It's a fraction of radiant energy that is diffused or received from one surface on the other surface directly without any intermediate reflection. And this shape factor is represented with F. Shape factor is represented with F. If I have to represent F12 here, it will be like the previous one I told you. Okay, it's like shape factor of body 1 with respect to body 2. Shape factor చాలా ఇంపార్టెంట్ కాన్సెప్ట్ అమ్మా, అర్థం కాకపోతే మళ్ళీ అడగండి, ఐ విల్ ఎక్స్ప్లెయిన్. సో ఇఫ్ ఐ హ్యావ్ టు క్వాంటిఫై దిస్ F12, F12 will be written like this: Q12 by Q1. So that is, it is a fraction of radiant energy that is diffused from one body and strikes the other body directly. Here, body 1 and body 2 we have. That's why from with respect to బాడీ 2 మనం బాడీ 1 కి రాస్తున్నాం కాబట్టి F12 అయింది. అది అలా కాకుండా F21 రాశాను అనుకోండి, ఇట్ విల్ బి లైక్ షేప్ ఫ్యాక్టర్ ఆఫ్ బాడీ 2 with respect to body 1. Okay, so then F21 will be like Q21 by Q1. Sorry, Q21 by Q2 అవ్వాలి. Should write Q2. So మీకు అర్థమవుతుంది కదా. So what's happening here is there are two bodies here. ఒక బాడీ నుంచి ఎమిట్ అయినటువంటి రేడియేషన్ లో ఇంకొక బాడీ ఎంత తీసుకుంటుంది అనే దాని రిప్రజెంటేషన్ షేప్ ఫ్యాక్టర్. ఓకే, దాన్ని రిప్రజెంట్ చేయడానికి మనం మ్యాథమెటికల్ గా ఈ యొక్క నామెన్క్లేచర్ ని వాడతాం. షేప్ ఫ్యాక్టర్ క్లియర్ కదా, అర్థమైందా? ఈజ్ ఇట్ క్లియర్? పలకండి, ఉన్నారా లేరా?
Yes, sir.
Yes, sir.
థ్యాంక్ యూ. సో నెక్స్ట్ థింగ్ ఏంటంటే ప్రాపర్టీస్ ఆర్ క్యారెక్టరిస్టిక్స్ ఆఫ్ షేప్ ఫ్యాక్టర్. ఓకే, ఫస్ట్ థింగ్ ఏంటంటే ఆ విషయం చెప్పే ముందు మిమ్మల్ని క్వశ్చన్ అడుగుతాను. ఇక్కడ నేను ఏం చేస్తానంటే నేను టూ బాడీస్ తీసుకుంటాను, ఇందాకలాగే ఈ బాడీస్ ని కాపీ చేస్తే బాడీస్ వస్తున్నాయి. Let me call this body as 3 and let me call this one more body here, this one as 4. ఈ బాడీ 3 ఉంది, ఈ బాడీ 4 ఉంది. Body 3 is emitting radiation onto body 4 like this. This is the kind of a thing. ఈ 3, 4 ని నేను ఎలా తీసుకున్నా అంటే A1 ఈక్వల్ టు A2 ఈక్వల్ టు A3 ఈక్వల్ టు A4 లాగా తీసుకున్నాను. ఇఫ్ దిస్ ఈస్ ద కేస్, కెన్ ఐ సే దట్ F12 ఈజ్ ఈక్వల్ టు F34? చెప్పండి. 1, 2, 3, 4 కి ఏరియా సేమే. అప్పుడు ఈ షేప్ ఫ్యాక్టర్స్ ఈక్వల్ అవుతాయా అవ్వవా? దట్స్ ద
No,
క్వశ్చన్.
no, sir.
దే విల్ నాట్ బి ఈక్వల్. దట్స్ కరెక్ట్. సో దీని నుంచి మనం ఏం చెప్పొచ్చు అంటే the shape factor depends on the geometry of the bodies. జామెట్రీ అంటే ఇక్కడ రెక్టాంగులర్ గా ఉంది, ఇప్పుడు ఇది కర్వ్ షేప్ కి స్పియర్ ని కానీ సిలిండర్ కానీ మీరు ఇక్కడ పెడితే అది A1, A2, A3, A4 ఈక్వల్ అయినా కూడా జామెట్రీ మీద డిపెండ్ అవుతుంది కాబట్టి షేప్ ఫ్యాక్టర్స్ మారిపోతాయి. అండ్ వన్ మోర్ థింగ్ ఇస్, నేనేం చేశా అంటే ఇప్పుడు ఇక్కడ ఉన్నటువంటి 1, 2 ని నేను కొంచెం ఇంక్లైన్ చేశాను. I have made it inclined. And 5 అంటున్నాను దీన్ని. This is body 5 and body 2 ని నేను ఇంక్లైన్ చేసి దాన్ని 6 అంటున్నా. Same bodies. Actually, I have changed the orientation here. So A1 is equal to A2 is equal to A5 is equal to A6. Areas are same bodies కాబట్టి can I say that F12 is equal to F56? Tell me. పలకండి. Will F12 equal to F56? No, they will not be equal. Why they will not be equal? Because see, మీరు ఇప్పుడు రేడియేషన్ తీసుకున్నారనుకోండి, ఇక్కడ ఇంతకు ముందు ఇక్కడ ఇది టచ్ అయ్యేది, ఇప్పుడు టచ్ కాదు. అక్కడ కొంచెం యాంగిల్ వచ్చింది కాబట్టి, కొంచెం ఓరియంటేషన్ చేంజ్ అయింది కాబట్టి, సో కొంచెం ఇంతకు ముందు టచ్ అయ్యేది ఇప్పుడు టచ్ కాకుండా పోతోంది, సో బయటికి పోతోంది. కింద కూడా అట్లా జరుగుతుంది. ఓన్లీ పార్ట్ ఆఫ్ ఇట్ ఈస్ బీయింగ్ టేకెన్ బై ద అదర్ బాడీ. సో దీన్ని బట్టి మనం ఏం చెప్పొచ్చు అంటే వన్ ఇంపార్టెంట్ ప్రాపర్టీ ఆఫ్ ద షేప్ ఫ్యాక్టర్ ఇస్ షేప్ ఫ్యాక్టర్ విల్ డిపెండ్ ఆన్ ఓరియంటేషన్ ఆల్సో. ఓరియంటేషన్ మీద కూడా ఇది ఆధారపడుతుందనే విషయం మనకి అర్థమవుతుంది. దట్స్ ద థింగ్ రిగార్డింగ్ orientation and the geometry. Let's come to the value of shape factor. షేప్ ఫ్యాక్టర్ మీరు ఐజే ఏవో 2 తీసుకున్నారనుకోండి, దాని యొక్క వాల్యూ ఎంత ఉంటుంది చెప్పండి. వాట్ విల్ బి ద షేప్ ఫ్యాక్టర్ రేంజ్?
Less
కెన్ ఇట్
than.
బి greater than 1? It
No, sir.
cannot be greater than 1. It will be ranging from 0 to 1. ఎందుకంటే మనము F12 అంటే ఏం చెప్పాము? ఇట్స్ Q12 by Q1. Q1 లోని పార్ట్, అది Q1 లోని ఫ్రాక్షనే Q12 కాబట్టి అది ఖచ్చితంగా లెస్ దాన్ ఉంటుంది. సమ్ లెసర్ వాల్యూ బై హయ్యర్ వాల్యూ విల్ ఆల్వేస్ బి లెసర్ దాన్ 1. సో shape factor value will always range from 0 to 1. These are the important things regarding. ఇంకొక ప్రాపర్టీ చూసేసి ఆ తర్వాత మనం క్లోజ్ చేసుకుందాం, నెక్స్ట్ క్లాస్ లో కంటిన్యూ చేద్దాం. సో నెక్స్ట్ ప్రాపర్టీ ఏంటంటే సమ్ ఆఫ్ షేప్ ఫ్యాక్టర్స్ ఆఫ్ ఎ బాడీ with respect to the surrounding bodies. Surrounding bodies is always equal to 1. Okay. So దీన్ని మీకు అర్థం కావడానికి I'll draw a simple figure here. ఇది బాడీ 1 అనుకోండి. దెన్ ఇక్కడ బాడీ 2 ఉంది అనుకుందాం. బాడీ 2, బాడీ 3, బాడీ 4, బాడీ 5 అండ్ బాడీ 6. ఇది దిస్ ఇస్ బాడీ 6. ఇవన్నీ కూడా అదర్ సైడ్ ఇన్సులేషన్ గా తీసుకోవాలి. It's insulated here, 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 here. See these are things. If Q is emitting radiation, a part of it is taken by 2. Sorry. A part of it is taken by 3. A part of it is taken by 4. A part of it is taken by 5. A part of it is taken by 6. Likewise, whatever the Q is there, this Q is distributed to all bodies here. So if I have to write it, it will be like Q1 that is emitted by body 1 will be taken by 2. The same thing will be distributed with 3. The same thing will be distributed with the 4. The same thing will be distributed with the 5. The same thing will be shared with 6 also. If this is the case, let me take this Q1 onto my left. That is, I will take this Q1 onto the denominator onto my right. So 1 will be equal to Q12 by Q plus Q13 by Q plus Q14 by, this is Q1 actually, 1 plus Q15 by Q1 by Q16 by Q1. So 1 is equal to F12 plus F13 plus F14 plus F15 plus F16. So what we have said? We have said that sum of the shape factors of a body with respect to the surrounding bodies is always equal to 1. So a body 1 with respect to the surrounding bodies, the sum of all the shape factors is equal to 1. So this is also an important property. We'll see one more property. Probably will take 2 minutes only for this one. This is shape factor of a body with respect to itself. Okay, this is one more concept here. That is, we take it as F11. Okay. If we take F11 here, this F11 for this particular body, చెప్పండి ఇక్కడ 1 ఉంది కదా, ఈ 1 దీని నుంచి ఎమిట్ అయిన రేడియేషన్ లో ఏమన్నా తీసుకుంటుందా? It won't take anything. If you take a body 1 here, whatever being emitted by this will not be taken by 1. It just goes out. So the F11 will be equal to 0 for flat surfaces. And let me take a convex body here. Convex body ante a circular shape. Okay, it can be a cylinder or a sphere, and it is emitting. When it is emitting, it will be emitting like this. Ila, ila, it will be emitting. When it is emitting, can it take something from it? It cannot take. Okay, అది ఎమిట్ చేస్తున్న రేడియేషన్ లో దాని దగ్గరికి ఏమి రావట్లేదు. కాబట్టి ఈ కేసులో కూడా, ఇఫ్ దిస్ ఈస్ యువర్ బాడీ 1, F11 will be equal to 0. And ఏంటంటే కాన్వెక్స్ సర్ఫేస్ కి కూడా F1 should be F11. That is, shape factor with respect to itself will be equal to 0. Now let me take the flat, the convex.
కాన్వెక్స్
Let
కి
me
ఇన్సులేషన్ పైన వస్తే అప్పుడు పాసిబుల్ అవుతుంది కదా.
entire
ఇన్సులేషన్ ఆపోజిట్ సైడ్ వేస్తే పాసిబుల్ అవుతుంది.
అది అప్పుడు కాన్వెక్స్ అవ్వదు, కాన్కేవ్ అవుతుంది. So let me take a concave body. Okay, this is a concave body, something like this. Then if I take the radiation being reflected out of this or emitted out of this, if you see, a part of it is taken by it here. ఇది ఇక్కడ ఇంటర్సెక్ట్ అవుతుంది, మొత్తం తీసుకుపోయినా దాంట్లో కొంచెము it is taken by that body itself, so it is not equal to 0 here. So this value is not equal to 0 for concave surfaces or bodies. Surfaces ని కానీ enclosures అని కానీ అనొచ్చు. So that's all for today. దీని కంటిన్యూషన్ మనము నెక్స్ట్ క్లాస్ లో చూద్దాం. దిస్ ఇస్ వెరీ ఇంపార్టెంట్ కాన్సెప్ట్. షేప్ ఫ్యాక్టర్ యొక్క కంటిన్యూషన్ నెక్స్ట్ క్లాస్ లో ఉంటుంది. జాయిన్. So one more thing is, let me stop this recording and speak about that.